What's up? I'm not streaming, am I? Blurred. This ain't working, bro. What the fuck? Your videos live. Am I? Blurred. This ain't working, bro. What the fuck? Oh, it's working, it's working, it's working. So, but this ain't working, by the way. So, I went to the glossary, so I had to stop that shit. Stop this shit, so. What I am confused about is okay.
The right results.
Previous state.
Let's save this, go back to the browser, click on increment, and the count is displayed as 5. Increment again, and the count is 10. We are able to correctly render the UI based on the state. The console values logged are from the synchronous console log statement and can be ignored for now. So this is the last do's and don'ts. When you have to update the state based on the previous state, make sure to pass in a function as an argument instead of the regular object. The function has access to the previous state, which can be used to calculate the new state. And as it turns out, the second parameter to this function is the props object. So if your new state is dependent on props as well, props dot add value maybe, you can go with the function parameter approach and make use of props.
Okay.
Okay, that is pretty much it. To quickly summarize, point number 1, always make use of set state and never modify the state directly. Second point, if certain code has to be executed after the state has been updated, place that code in the callback function, which is the second argument to the setState method. And finally, in this video, let's learn about component state in React. As we have seen so far, every React component returns JSX, which describes the user interface. And in the last video, we saw that it is possible to influence what is rendered on the screen using props. As it turns out, there is a second way to influence what is rendered on the screen, and that is the state of the component. Let's quickly review what we've learned about props and make a comparison by learning about state. After that, let's dive into an example to get a better understanding of how state works in React components. Alright guys, before we move on to the next topic, I want to take a few minutes to quickly go over destructuring props and state in React. Destructuring is an ES6 feature that makes it possible to unpack values from arrays or properties from objects into distinct variables. In React, destructuring props and state improves code readability. You're also more likely going to find the destructuring syntax in most of the online material, and that is the reason I want to go over this topic. Let's start with functional components. Earlier in the series, we had created a functional component called greet. In app.js, you can see that we are passing in name and hero name as props. And in the greet component, we access them using props.name and props.heroName. Now there are two ways to destructure props in a functional component. The first way is to destructure it in the function parameter itself. So instead of just props, we're going to have parentheses, and within the parentheses, we have the destructuring using curly braces. Name, comma, hero name. We are basically extracting name and hero name from the props object. In the JSX, we can now simply use name and hero name instead of props.name and props.hero name.
Yeah, I know this. Like destructuring, like prop equals to with state both name, comma, state last name. It is because we cannot change the value of prop in here, so understand this. Okay, prop is an object. If this is this, look at this. This curly bracket means an object, so, and this means an array. Okay, understand that part. And then curly bracket, so it has name, comma, in my case it's last name, but in his case it's hero name. I'm gonna make you understand from hero name, because I think you will understand from what I say if I do this. In props contains both names and heroes, so and so cut this. Okay, then props equals to this because it gets that from app.js. Look at here, name, in his case this is hero name and it's Batman or something, so in my case it's last name. And if we run this prop, where is that bruh? Greet. Okay, the props take all of the fucking properties that is given, and if we do this we did, prop contains name, which is done for an object. If we directly do this, in my case, name, name, comma, last name, so it's directly taking props dot name equals no, like they're taking like name props dot name types it, and same for the last name last name. It's like saying this. So this structuring means like we are destructuring the prop to name and last name, so it makes our code cleaner and easier to read. Like if we wrote prop and we need to like search for this value, so search for this value, or see the app.js to know what the properties really are. And but if we do this, we can really understand that we only take name and last name. Okay, that much. So we can directly write like this. So children is not taken, so children. So by the way, if you don't understand what children really is, like let me like make it so that this is a comment. If you don't know this, go back, bruh. Just learn some. Okay, it needs to have one parent. It's app. What? Oh fucking wait, I know where I gone wrong. To here, and then we need to like delete this up to here, so it becomes it doesn't read this, and save, and look at here. It's like hello Aaron Gohatras, first name, last name, and children is this. Children is like in between the tags. Like this is an self-closing tag because it closes itself, so we don't need to like greet bracket close. So it's a self-closing tag because slash is in the last, and children is like passed as property because like in between the closing and open and closing tag there is a fucking HTML which is passed as a children children passed as children. So like properties props dot children. So object contains the HTML too, so like we're displaying the HTML in here. I hope you understand, because like if I make you understand, I understand it too, by the way. Okay, this is cool. Good. I'm taking way too much time on React stuff.
Let me also remove the console log statement, and if you take a look at the browser, you can see that the app still works. So that is the first way, destructuring in the parameter. The second way is to destructure it in the function body. So we go back to naming the parameter as props, and in the body, const, curly braces, name, comma, hero name is equal to props.
This is also the same, like const name equals to hero name becomes prop.
So we
from prop
name and hero name property from the props object. After this, you can use just name and hero name in the JSX. Go back to the browser, and it should still work as expected. So these are the two ways to destructure props in functional components. Next, let's take a look at class components. I'm going to open welcome.js, which is our class component. This component also accepts the same two props, name and hero name. Now in class components, we generally tend to destructure props or state in the render method. So const name, hero name is equal to this dot props. So on the left hand side, curly braces.
Because like in classes we need to write this like I don't really know the word, but we need to write this to do the property stuff.
Name, hero name, and on the right hand side, this dot props. Again, we are simply extracting the necessary props. Your props object could contain 10 different props, but you can destructure only the ones you wish to use in your component. So in the JSX, I can now remove this dot props. If you take a look at the browser, you should have welcome Bruce, aka Batman, which is from our welcome component. Now on similar lines, you might also have a number of state properties. You can destructure them in a similar way. Const, then curly braces, state 1, state 2 is going to be equal to this dot state. Now we don't really have state in this component, but this is the syntax you will come across. So that is pretty much what I have on destructuring props and state in React. I will make use of the same syntax going forward, so please do make a note of this. Alright, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Any web application you create typically tends to have user interaction. When the user interacts with your application, events are fired. For example, mouse clicks, mouse over, key press, change event, and so on. The application must handle such events and execute the necessary code. In this video, let's see how to handle events in React. We will focus on just the click event, but the concept holds good for other events as well. Let's begin with functional components. I'm going to create a new file called functionClick.js.
What? Ow. Oh, sorry. What is even handling? Okay.
In this video, let's see how to handle events in React. We will focus on just the click event, but the concept holds good for other events as well.
Okay.
Let's begin with functional components. I'm going to create a new file called functionClick.js.
I will read this.
Within the file, I am going to create a new using the React snippet RFCE. As part of the HTML or JSX, I will add a button that says click. Next, let me add the component in the app component. So within the return statement,
like
function click. Make sure to import it as well. If you save the files and take a look at the browser, you should be able to see the click button. When the user clicks on this button, a click event is fired. Our goal is to capture that click event and execute some basic code.
what?
The first point you have to make note of is React events are named using camel case rather than lowercase. In plain HTML and vanilla JavaScript, you would specify on click. But in React, it has to be camel cased. So C has to be uppercase on click. The second point is with JSX, you pass a function as the event handler rather than a string. So instead of click handler within double quotes, you're going to have click handler within curly braces.
Bro, I need to download Emmet, bro. If you don't know, Emmet is like autofiller. Like when you do like this in HTML and click, then it write a fucking dummy or static page for HTML to get it started, brother. I got that. Emmet, Emmet. Not this React. Trust, okay, this is what I wanted. Okay, does it work in this or is it just HTML? Like if I write div, okay, it works. So this is the main problem. I was fucking button. It doesn't work for self-closing tag, so that's
Now let's define the click handler function. Remember, in JavaScript, it is very much possible to define a function within another function. So inside the functional component, we can define our click handler. So function click handler, and within the body, we simply log to the console button clicked. Let's save this and test it out. If I open the developer tools and the console tab and click on the button, you should see the message button clicked in the console. Our click event handling works as expected. Now, let me point out one of the more common mistakes we as beginners tend to make with event handling.
You as a beginner,
In our code, you can see that on click, we pass the function as the event handler. Pay close attention to the absence of parentheses. If you do add parentheses, it becomes a function call, and that is not what we want. We want the handler to be a function and
no, I fucking printed it wrong. So let's go at the bottom. Bruh, I need Emmet. Okay.
Me, if I think that AI will replace software engineers. And I want to talk about that and share my opinion in this video. First of all, I basically use AI to write all of my code now. Like 99% of my code is written using AI. And I try to use the latest models and tools as they are released. So right now I'm using the model Claude 4.5 Opus, but it may be something different depending on when you're watching this video. So I try to use these tools as much as I can, and as I use these every day, I'm not seeing how they are replacing engineers. The way that I see things is that there are two main ways that I see myself and other people using AI. The first way is called vibe coding, when we're telling the AI to work on an app or a feature, and we don't look at the code at all. We let the AI handle all of the code itself. And the other way that I see people using AI is just regular software engineering. So like we tell the AI to generate the code, but then we also review the code to make sure that we understand exactly what's going on. And by the way, I do both of these things. So I have a side project that I like to work on, and I use vibe coding there because I just want the product to work. I don't really care about how the code looks. I just want something working so that I can get users and I can get some feedback. Now, when I'm working at a tech company, I have to use regular software engineering because, for one, I need to understand exactly how that code works. That's part of the responsibilities that I have. And number two, I've also noticed that vibe coding, or letting the AI handle all the code, actually does have its limits. But before I talk about that, in using AI to vibe code and to do regular software engineering, I've noticed that it's a very collaborative process, both when I'm using it and when I see other people using it online and in real life. So we're basically giving the AI a task to do, the AI comes back, and then we check its work to see if it's correct. Maybe we need to fix something, maybe we forgot to tell the AI something, or maybe the AI misunderstood us. But in all cases, we're going back and forth with the AI and giving it tasks and then adjusting based on the results and the work that it does. And also sometimes maybe I don't understand something, so I would ask questions to the AI and we would have a whole conversation back and forth. So basically, as I'm using these tools, I'm thinking to myself, it's a lot of back and forth collaboration with this tool, rather than something that is replacing me or replacing someone who's using this tool. And so I don't really see the angle of AI replacing software engineers or AI replacing anyone that's using this tool.
He's good at teaching stuff, bro. He's good at it. And I'm not like emphasizing more, but they are. Okay, let's down. Cause if I go down, like he too is doing his stuff, like coding in the hood, bro. What the fuck?
I want to go back to the point that I talked about, where I started to hit as all the software engineers who have the coding skills and who have all the other core software.
Not a function call. Let's quickly see what happens if we do leave the parentheses.
Oh.
We're going to save this and go back to the browser, and you can see that in the console, the message button click is already logged.
You can do
And
like
this
this
is
too.
not from our previous button click. So I'm going to clear the log, and now when I click on the button, it renders is that the event handler is a function and not a function call. To React.js, and within the file, I'm going to use the React snippet RCE to create a class component. I will get rid of the name export and include the component in app component.
What is the snippet?
In the file, I'm going to use the React snippet RCE to create a class component. I will get rid of the name export and include the component in app component.
Or, wait. Import. I need to learn this, brother. React. We need component in this shit. component component from React and class. In React, like the common habit is that we need the same function name as the fucking file name, because it's like better that way. Extends to component to make a class. So like render return has this, and div. What I don't understand is class in React. Oh, why is it as a real index? React moved the function component as the default assumption. Why they figure out hooks? But now it has more tools than class component really ever had, and it's not a matter of should I use, because of the choice is obvious. If you want to use any major feature released in the past, you use a function component, because class component do not support hooks. The reason not to is if you're stuck using earlier, you need state or context, so your code. Okay, I figure out that class is not really like what I see day-to-day basis, like when I well when I see randomly on the fucking GitHub or shit. Like for class component is not that used widely, by the way. Mostly I find function component
and include the component in app component. Again, make sure you import the component at the top. In the class click component JSX, I will simply add a button with the text click me. If you take a look at the browser, you should be able to see the button. Now adding a click event handler in a class component is very similar to functional component. We have the onClick attribute, in camel case of course, and this is going to be equal to curly braces, and within the curly braces, the handler. But in a class component, methods will be accessed using the this keyword. So this dot click handler. Now we can define the method in the class. So right above the render method, click handler, and we simply log to the console, click the button.
Handler.
Again, make sure
in React we use camel case, like C is capital, S is capital. I think no, that's not camel case, that's other stuff. But in JavaScript, this is JavaScript, if we use parentheses, so we use like camel case. This is camel case, like first letter of the word is small, and then anything attached to it, the word, is capital. So remember that, brothers. So we need to say stop. This fucking AI is taking our job, brother. And React is kind of like in the neck of like fucking hell, brother. I would have been more involved in coding stuff if it wasn't for AI, and AI has helped me learn stuff. But fuck AI, brother. I'm sorry about that, but fuck AI, bro. Fuck you, bro. I know it becomes easy, bro, but I'm still a fucking beginner. I need to get into tech, brother. Okay. I'm sorry, I crossed out, bro.
You don't add parentheses to the handler. If you now save the file and take a look at the browser, when I click on the click me button, you should see the message click the button in the console. So that is basically how you handle events in a functional component and a class component. Camel case for the event, and specify a function or a method within curly braces. Event handling looks pretty simple right now because we are not doing much in our event handler. But generally, your event handlers tend to modify the state of the component using this .setState method. And when you try to do that, you kind of run into a whole world of confusion. All the confusion revolves around this keyword binding in JavaScript. So let's take a detailed look at binding event handlers in the next video.
So this is the last. So after this, let me look at tomorrow's videos. 8 minutes, 11 minutes, 12, 7, 11, 11. Fuck, man. Up to 21. So tomorrow is gonna be a long day.
In this video,
Cause
let's talk about
Cause like 8 was 11, 11, 10, 14, 4, 7, and I'm still kind of like thinking that this is a long. The first live stream was broken because I went away for a minute, so like it stopped the stream by itself. So like it was like 2 hours, 3 hours, and including this is 3 hours and something minutes, I think. It's taking me long.
In this video, let's learn how to bind event handlers in React components. Before we begin, let me tell you that the reason we bind event handlers in React is purely because of the way this keyword works in JavaScript. It is not because of how React works. I will give you a very simple example in the context of React components to help you understand why event binding is required. But my recommendation here for you is to go through this keyword and how the value of this keyword is determined in JavaScript. This video will make much more sense to you once you're comfortable with the basics of this keyword in JavaScript. Alright, let's get started. What I want to achieve in this video is on the click of a button, we simply change a message which is part of the component state. So first, I am going to create a new file called eventbind.js. Within the file, I will use the React snippet RCE to create a class component. I will remove.
Brother, I need to decide whether should I learn. Grog is my safest bet.
the name export and include the component in the app component. The CE to create a class component. I will remove the name export and include the component in the app component. For the JSX, I will simply add a button that says click.
Fuck it, man.
Now if I save the file and take a look at the browser, you should be able to see the button click. Next, let's create.
Let's just understand, bruh. In 2x.
Now if I save the file and take a look at the browser, you should be able to see the button click. Next, let's create a state property called message and bind it to the user interface. So in the component, I'm going to add a constructor using the snippet rconst. Within the constructor, I call the super and
constructor props. Mixed it.
A state property called message with the content this dot state dot message. If you save the file and take a look at the browser, you should be able to see the message hello. Now let's change this message to goodbye when the user clicks on the button. Recollecting from the last video, we add the onClick attribute.
OnClick this a function name and then
mute, and then we pass in the event handler within curly braces. This dot click handler, and let's define the method right after the constructor click handler. And to change state, we need to use the setState method. This dot setState, and we want to set the message to goodbye. If I save this and go back to the browser and click on the button, you can see that our application breaks. And if you take a closer look at the error, it says cannot read properly setState of undefined. So let me go back to VS Code and comment out the setState method.
Why is this not working? This does set props.
And instead, simply log to the console this keyword. Now, if you go back to the browser and click on the button, you can see that undefined is logged in the console. So this keyword within our event handler is undefined. And let me tell you, this is the typical behavior in JavaScript. I won't go into the details of why it is undefined though. It is JavaScript related and not React specific. Please do spend a few minutes reading up on this keyword if you want to understand why the value is undefined. But what I want you to ultimately keep in mind is this keyword is undefined in an event handler, and that is the reason event binding is necessary in React class components. Now there are a number of ways to bind event handlers in React. When you go through articles or blog posts or other videos, you might find all different variants of binding the event handlers. So in this video, I will go over all of them. The first option we have is to use the bind keyword and bind the handler in the render method. So on click, this dot click handler dot bind, and we pass in this keyword. Now let me also uncomment setState. Let's save the file and go back to the browser. Now when I click on the button, you can see that the setState method works without any errors. The message now reads goodbye. And this keyword, as you can see in the console, is not undefined anymore. It refers to the event bind component instance. Although this option works perfectly fine, every update to the state will cause the component to re-render.
Sorry about that. My friends called about the nice day tomorrow, so I won't be streaming anything tomorrow. So that's it.
So on click, this dot click handler dot bind, and we pass in this keyword. Now let me also uncomment set state. Let's save the file. Go back to the browser.
Why you use bind, by the way?
So in this video, I will go over all of them. So this keyword action method, and after the constructor, the constructor to click start of alright class component. Within the file, I will use the React snippet RCE to create a class component.
Okay.
One, binding in the render method.
Let's not make this because we don't have state in this right now. Button no, bro, I didn't understand that, so go back.
Cannot and dot set state.
And so on click, the click handler. I don't want to half-ass this, so I'm learning this. Click, so okay, on click, okay. Constructor. The first initial value of the state message is hello, so I think it's gonna run so we need to write this and this dot state dot click. We don't need to like declare it here in class. I don't know why, but changing the state of message.
And we want to set the message to goodbye. If I take this and go back to the browser and click on the button, you can see that our application breaks. And if you take a closer look at the error, it says,
where is the app?
cannot read property set state of undefined. So let me go back to VS Code and comment out the set state method, and instead simply log to the console this keyword. Now if you go back to the browser and click on the button, you can see that undefined is logged in the console. So this keyword within our event handler is undefined. And let me tell you, this is the typical behavior in JavaScript. I won't go into the details of why it is undefined though. It is JavaScript related and not React specific. Please do spend a few minutes reading up on this keyword if you want to understand why the value is undefined. But what I want you to ultimately keep in mind is this keyword is undefined in an event handler, and that is the reason event binding is necessary in React class components. Now there are a number of ways to learn this. I won't go into the details of why it is undefined though. It is JavaScript related and not React specific. Please do spend a few minutes reading up on this keyword if you want to understand why the value is undefined. But what I want you to ultimately keep in mind is this keyword is undefined in an event handler, and that is the reason event binding is necessary in React class components. Now there are a number of ways to bind event handlers in React. When you go through articles or blog posts or other videos, you might find all different variants of binding the event handlers. So in this video, I will go over all of them. The first option we have is to use the bind keyword and bind the handler in the render method. So on click, this dot click handler dot bind, and we pass in this keyword. Now let me also uncomment set state. Let's save the file and go back to the browser. We bind the handler in the render method. So on click, use and instead simply log to the console this keyword. Now if you go back to the browser and click on the button, you can see that undefined is logged. Now if you go back to the browser and click on the button, you can see that undefined is logged in the console. So this keyword within our event handler is undefined. And let me tell you, this is the typical behavior in JavaScript. I won't go into the details of why it is undefined though. It is JavaScript related and not React specific. Please do spend a few minutes reading up on this keyword if you want to understand why the value is undefined. But what I want you to ultimately keep in mind is undefined in an event handler, and that is the reason event binding is necessary in React class components. Okay. Now there are a number of ways to bind event handlers in React. When you go to articles or blog posts or other videos, you might find all different variants of binding the event handlers. So in this video, I will go over all of them. The first option we have is to use the bind keyword and bind the handler in the render method. So on click, this dot click handler dot bind, and we pass in this keyword. Now let me also uncomment set state. Let's save the file and go back to the browser. Now when I click on the button, you can see that the set state. Let's save the. Now let me also uncomment set state. Let's save the file and go back to the browser. Now when I click on the button, you can see that the set state method works without any errors. The file and go back to the browser. Set state. Let's save the file and go back to the browser. Now when I click on the button, you can see that the setState method works without any errors. The message now reads goodbye. And this keyword, as you can see in the console, is not undefined anymore. It refers to the event bind component instance. Although this option works perfectly fine, every update to the state will cause the component to re-render. This in turn will generate a brand new event handler on every render. Although the impact on performance is not severe in small applications, it could be troublesome in large applications and components that contain nested children components. So approach 1, binding in the render method. The second approach is to use arrow functions in the render method. So let me comment out the first approach and show you the second one.
Okay.
The arrow function approach is simply calling the event handler in the arrow function body. So on click, and within curly braces, we are going to have an arrow function. Empty parentheses, fat arrow syntax, and then the event handler. This dot click handler. Notice that we don't need curly braces or the return keyword for the arrow function body. And that is because the function body is a single statement. Also, you can notice that we are calling the event handler and returning that value. That is why parentheses is required in this approach. If I now save the file and take a look at the browser, clear the console and click on the button, you can see that the message changes from hello to goodbye. So the second approach also works as expected. But similar to the first approach, this also has performance implications in some scenarios.
हजुर
हेलो
हजुर
सटर पनि लगाउ बाइक कताबाट
के रे
काजा लगाउ च्यानल गेट बन्ने
मैले फुल कुरा सुनिन के
सटर बन्द गरेको छ होला सटर बन्द गरेको सटर बाइक राखेको छ सटर बन्द गरेर काँचमा गेट पनि चाबी लाएर
Fuck,
If you can recollect, this is the approach we used in the previous few videos. So the second approach is using arrow functions in the render method. Next, let's discuss approach number 3. And this is the approach you're going to see in most of the cases, and it is also the approach in the official React documentation. This approach has we simply click handler line. This dot click handler is equal to this dot click handler dot bind and pass in this keyword. And in the render method, we can go back to, and in the render method, we can go back to this dot click handler equal to this dot click handler dot bind and pass in this keyword. And in the render method, we can go back to this dot click handler. Save the file, go back to the browser, clear the console, and click on the button. You should be able to see the message change from hello to goodbye. This dot click handler. Save the file, go back to the browser, clear the console, and click on the button. You should be able to see the message change from hello to goodbye. So that is the third approach, binding in the class constructor. Because the binding happens once in the constructor, this is better compared to binding in the render method. So approach number 3, binding in the constructor. The final approach is to use an arrow function as a class property. Basically, change the way you define your method in the class. Let me comment out the binding in the constructor, the existing click handler, and now define it with the new approach. Click handler is going to be equal to an arrow function, and with the arrow function, this dot set state message set to goodbye. If you save the file and take a look at the browser, you can see that the message changes on a button click. This keyword has the expected value within the handler method. So those are the 4 approaches: binding in vendor, arrow function in vendor, binding in the class constructor, and finally class property as arrow functions. The first approach is something you might not want to use because of performance implications. The second approach, although it's similar to approach number 1, is probably the easiest way to pass parameters. If your code doesn't involve re-rendering nested children components, this approach is still a viable option. React documentation suggests either approach number 3 or approach sub-approach.
Guys, it's finished, and so I'm gonna eat dinner. So if I really want to pause this shit, but you're gonna be staying idle for a minute. So like YouTube, listen to some songs, bruh. I don't really know. Listen to some Rain, bruh. Rain is good. Rainy.
Jinx's update will save Clash.
Bro, hear this, hear this.
Most importantly, the six-figure salary! Called internal pointer variable. Maintains no more than one unmarketable token. I thought I knew how to code!
Bro, hear this, hear this.
I don't never know how to code! What is this even in English?
Liar, bro. Wait, this is a phase of me, bro. Of like watching.
There's this tweet from this Anthropic engineer about a month ago that said software engineering was going to be over by the first half of 2026, which would be scary, except that 6 months before that, the CEO of Anthropic said that 90% of code was going to be written by AI and we weren't going to need any software engineers within the next 6 months, which would be even scarier, except that a few months before that, the CEO of NVIDIA, Jensen Huang, said that nobody was going to need to learn to code anymore because of AI. Quoting this absolutely phenomenal tweet, software engineering has been within 6 months of being dead continually since early 2023. As a software engineer, this obviously begs the question, what the fuck? Is my job being taken over by AI or not? And if you're not already in the field, you might be thinking, is it too late for me to get into this field? Is it too late for me to learn to code? So I'm going to try to answer these questions in this video, but I'm going to preface this whole thing by saying I'm a programmer, not a magician. Meaning I am someone who's been in this field for a number of years. I do understand the underlying technology, but I'm not going to be able to predict with 100% accuracy what happens to software engineering or other programming jobs. And the reason for that, first of all, is this isn't a fully technical question. People are really focused on whether AI is good enough to replace programmers. But that's only half of the equation. Consider a world where AI-generated code, or vibe code, as a lot of you guys call it, didn't really work. Like, let's say it didn't really ever compile. Maybe it only compiled 5% of the time. There would still be nothing stopping leaders from firing all the programmers, letting the AI at it, and just crossing their fingers and hoping it all works for the best. Of course, that's not the state of AI coding these days. AI coding is getting really good. Everybody and their mother is making an app with Lovable or Bolt or Replit. Even many experienced programmers, including myself, are using AI in their day-to-day work. But I just give this hypothetical to explain that this is a 50% technical problem and a 50% people problem. And there's really no good way for me to answer the people problem definitively. So because of that, I think the best way to look at this problem is in terms of a spectrum of risk. Now, on one side of the spectrum, we have AI fully automates every single technical job, and there's no jobs left for us. Now, I don't think that's going to happen. I think if that did happen, it would also take every single desk job in the entire economy, crash the economy, and at that point, it also probably doesn't matter if you learned code or became an accountant because society has collapsed. And then on the other side of the spectrum, we have AI for coding doesn't get much better than it currently is now. Companies also decide they don't want to embrace it any more than they already have, and programming jobs for that reason are completely safe. Now, I think most of us can probably agree that the truth lies somewhere between those two extremes on the spectrum. So I want to go through two different options of how I can see this actually playing out, both of which are more in the middle of the spectrum. The first is that AI might continue to get better, and a lot of the day-to-day work that programmers do, like writing out a for loop, might get permanently delegated to an AI. But instead of getting rid of the job of programmer might just fundamentally change. This is what I'm already starting to see in my job as a software engineer, where I am letting the AI start to do a lot of the grunt work, like writing out a unit test, like setting up all the boilerplate in a file, even writing out the specific business logic if I can explain that business logic in plain English. But I'm still the one making high-level decisions about how we're building something, and I'm still the one debugging when something breaks, which unfortunately does happen regardless of whether I'm vibe coding or not. And this is sort of the whole argument about why the junior market is drying up for programmers, but the senior staff plus market is still going strong. Right now, we associate being able to debug something across a complicated system or make a decision about what framework to use as more like a senior skill. But it's possible that might not always be the case. With AI, it is easier to pick up some of these skills, and if junior devs aren't spending 8 hours of their day learning about esoteric syntax patterns of Rust, maybe they'll be able to pick up these other skills a little bit faster. So one of the outcomes of AI coding becoming so prevalent might be that coders as a job still exist, but the main attribute of that job is no longer coding. Now, before I tell you my second possible prediction for the coding job market, I want to pause and answer the question of, is it specifically worth it to learn to code if the job market of the future might be less focused on the act of coding? Like I was saying before, diving deep into X is probably not the best use of your time. But at the end of the day, it's hard to build up other technical skills if you don't have the foundation of coding. Coding is what everything else is built on top of, so it's going to come in handy for a lot of technical work. And just to give a very concrete example, if you need to know how to debug, like I was explaining before, to debug is to know what's wrong with the code. And to know what's wrong with the code, you have to understand what the code is doing in the first place. So yes, I really do recommend specifically learning to code. And the best way to learn to do that, if you're new to coding, is picking a popular programming language and learning how to build something with it. If you don't know which language to pick, I recommend Python. It's pretty beginner friendly. It's been picked pretty consistently as one of the top programming languages for developers, and it's become the de facto language for a lot of ML and AI projects, which these days is a lot of projects. And if you do decide to learn Python in 2026, I highly recommend DataCamp. It's one of the most hands-on ways to actually build your programming skills. Their Python programming fundamentals track is perfect if you're just starting out. You'll go from the absolute basics like variables developer, the associate Python developer track dives even deeper, covering concepts like object-oriented programming, regular expressions, decorators, and even real-world projects like web scraping and file management apps. So if you want to master Python to build AI applications and jumpstart your programming career, check out the links in the description. Now, getting back to that second possibility about what might happen to programmers, I want to warn you guys, this one's a little bit more woo-woo, a little bit more out there. But there might be an outcome where the job of software engineer is replaced with a totally different technical role. So in this situation, AI would be replacing a lot of what it means to be a software engineer, including these more complex pieces of it, like debugging. Which I know AI can debug now, but it's not always amazing at it, and you'll know that if you've ever been stuck in one of those vibe coding loops that's like, it's broken, please fix it. You're absolutely right, it is broken, I have fixed it. It is not fixed, please fix it. You're absolutely right, I did not fix it, but now I have fixed it. It's still not fixed. You get the point. But even in the case where AI is really good at debugging, it can take over a lot of aspects of software engineering, where the industry looks totally different. I still think there will be technical roles that need to be filled. Now, what these roles actually are, I think might look very different from the roles we have today of software engineer, data scientist, product manager. It might be the primary technical role here is like overseeing a team of AI agents, or figuring out and investigating when things aren't working correctly and the AI agents aren't building what they're supposed to be building. It might be that the next big role is the people that are setting up these AI systems, and that use their expertise to advise on the best way for companies to set up AI workflows. Listen, don't quote me on any of this. This is all theoretical, but there's two reasons I think this might be the place we end up. The first is coming back to the people problem of all this. I think a lot of decision makers really want a human to tell them what to do. Even if all of the above could be automated, people really want another human guiding them in the right direction for these really important decisions. The second thing is that all we know for sure right now is that the future is computers. The future is more investments in AI, more investments in technology at large. So it kind of just makes sense to me that if any new jobs are created out of all of these technological breakthroughs, the new jobs are going to be in the tech industry. Now, I can't tell you what the exact qualifications of these jobs are going to be because they don't exist. But regardless of what the impact is of AI on programming, I do genuinely think that there are going to be some technical roles doing something. Now, if you are very attached to your job specifically being writing out lines of code by hand, then yeah, I think at this point it is probably too risky to try to pursue that specific day-to-day job. But if you do feel like you can be flexible, if you feel like you'd be willing to pivot what your actual day-to-day work looks like down the line, as long as it's something technical, then I do think it is worth it to pursue a career in programming right now. Now, how do you prepare for a technical career like that? First, I think it's definitely worth it to stay up to date with the latest tech and AI research, at least just like at a high level, because that way you can know where the industry is heading. I also think it's worth it to learn more quickly these skills that have traditionally been considered more senior, such as debugging a really big system or system design overall, because I think that those things might come in handy earlier into your career. And finally, as I mentioned before, I do think it's worth it to learn to code, to have that fundamental understanding of the technology. So I hope this video smoothed out some fears about where the tech industry is heading, and hopefully didn't introduce too many new ones. If you want to learn to code, if you want to come join me over in the tech industry, come on over. We can go down in flames together. Just kidding. Probably.
Is it still worth it learning how to code in the age of AI? Here's the answer.
And I think one of the big debates is like, should we still teach our kids to program computers? Even though you're going to have these tools in the future that are just so much more. more powerful than anything that we have now to produce incredibly complicated pieces of software? I think the answer to that is probably yes, because I think teaching someone how to code is teaching them a way to think rigorously, and that even if they're not doing most of the code production, I think it's important that you kind of have the ability to think in that way, and I think it's going to just make you generally a better thinker and better person.
Okay, we have another question here, which is, Ali, I have a question. Is it better if I know how to code, or should I not be bothered learning how to code because of AI? Right now, I'm learning coding to launch something on my own. I think even in the world of AI, and actually especially in the world of AI, it's still very useful to learn to know how to code.
Everybody who sits on a stage like this would tell you it is vital that your children learn computer science. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program.
I have a controversial argument against what Jensen said. This one will probably piss some people off. My argument is that even if everything that Jensen predicts comes true, and in the future you will be able to build a great app just by writing English, you should still learn how to code, because learning how to code will literally make you smarter. We have an interesting piece of evidence for this, which is there's a lot of studies now that show that the way LLMs learn to think logically is by reading all the code in GitHub and basically learning how to code. And I think programmers have long suspected this, that learning how to code made them smarter, but it was kind of hard to prove with humans, and now we have some actual evidence that this is really true.
Everybody who sits on a stage like this would tell you it is vital that your children learn computer science. And in fact, it's almost exactly the opposite. It is our job.
So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run. And the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been YouTube comments, people sliding in my DMs, in the Discord server that I run, and the question is, look, is it still even worth learning to code in 2025? And honestly, I get why people are asking this. The job market is brutal out there right now. And not only brutal for junior engineers just trying to get their first job, but brutal for everyone, for junior engineers, for mids and seniors, for technical leads, for project managers, everybody. Anybody that's involved in this technical space is having one heck of a time trying to find a job right now. So I've been getting this question a lot, whether it's been...
I still have smile when people tell me that programmers will be replaced by no-code tools and AI. Those people don't even have the slightest idea how complex software can become, and then they usually come with, oh, software developers are overpaid. So when people tell you this, don't feel bad, because that usually comes from people who don't have any serious skills by themselves and now need to blame those who had to earn serious skills over years and decades. I still have smile when people tell me that programmers will be replaced by no-code tools and AI. Those people don't even...
So the coders that are coding traditionally today, how will they be using and working in this industry 2 to 5 years from now?
There will be no coder that doesn't use AI as part of their workflow.
I mean, I think that's the important thing. It's not like coders are going to go away. They're going to be using a new set of tools.
All the barriers to creating programs disappear. It's not that there are no programmers, there's no programmers who know it, because there's a billion programmers. Everyone is a programmer, nobody's a programmer in a way. It's more about understanding information flows, it's about architecting these things, it's about having feedback loops to understand customer requirements.
The nature of coding is going to change. So the coders that are coding traditionally today, how will they be using and working in this industry 2 to 5 years from now?
There will be no coder that doesn't use AI as part of their workflow.
I mean, I think that's the important thing. It's not like coders are going to go away. They're going to be using a new set of tools.
All the barriers to creating programs disappear. It's not that there are no programmers, there's no programmers who know it, because there's a billion programmers. Everyone is a programmer, nobody's a programmer in a way. It's more about understanding information.
I think this year, probably in 2025, we at Meta, as well as the other companies that are basically working on this, are going to have an AI that can effectively be a sort of mid-level engineer that you have at your company that can write code. And once you have that, then in the beginning it'll be really expensive to run, and then you can get it to be more efficient, and then over time we'll get to the point where a lot of the code in our apps and including the AI that we generate is actually going to be built by AI engineers instead of people engineers. But I don't know. I think that that'll augment the people working on it. So I mean, my view on this is like, the future, people are just going to be so much more creative, and they're going to be freed up to do kind of crazy things. I think this year, probably in 2025, we at Meta, as well as the other companies that are basically working on this, are going to have an AI that can effectively be a sort of mid-level.
Is it even worth learning programming in 2025 with all the layoffs and AI about to take our jobs? Here's the thing, it is and it isn't. Traditionally in programming, we've seen a lot of people enter the field just because they want an easy way into a six-figure job, but a lot of those developers never actually had any real interest in programming to begin with, so the result was they learned what they needed to get the job, but then they sort of stagnated. And what this means is while there is a huge overinflation of people in the programming industry, it's still hard to find actual good programmers. And while yes, AI is pretty close to just making a lot of programmers' jobs obsolete, like you can pretty much use AI to replace a couple junior engineers at this point, I still think there is a large need for really good engineers. And that means if you are actually interested in programming and you take the time to actually learn stuff instead of just using AI to make everything yourself, and you actually build in public and you do things and launch things, actually learn what software in the real world that is being used by real people looks like instead of just small projects and weather apps and Twitter clones that you do in your spare time. So yes, if you're one of those people, programming is still worth learning. But if you're just someone that's trying to sort of get a quick pass into a high-paying job, I think the era for that is sort of over. And now moving forward, we're probably going to see a lot less opportunity for sort of mid-level engineers and a lot of opportunity for great engineers. And if you actually are trying to learn, being consistent is the #1 piece of advice I could give give you. And the number 2 piece of advice is make stuff that you intend on other people to use. You are not going to learn nearly as much by building small little projects for yourself as you will building something that you anticipate other people to use and actually put it out in the world to get real feedback. I personally love building and shipping something every single day, and it's one of my goals to ship something every single day of 2025. So I built this little thing called dailyship.dev. You can check it out in my bio, but it's
I got this question on this channel. Hey Mosh, I'm 30 and I was planning to start a career as a programmer. Do you think this is wise? Common question. A lot of people are worried that AI is going to replace software engineers. So is coding still worth learning in 2024? Well, it depends who you ask. If you ask certain folks, the ones who always seem miserable and say everything is going to collapse, they will say no. Coding has no future. But I've got a different take, backed up by real-world numbers. Check out my full video where I show data that shows the continued demand for software engineers.
Should you still learn to code in 2025? Absolutely. Coding isn't going anywhere, just like farming hasn't gone anywhere. It's the backbone of robotics and automation. But don't be the farmer who refused to learn how to use the Reaper. If you are planning on learning how to code in 2025, then you also need to do it with AI. Should you still learn to code in 2025? Absolutely. Coding isn't going anywhere.
Software development, dying. I mean, every day it seems like a new coding AI tool is coming out. Not to mention...
Is it still worth becoming a software engineer, even with AI taking over and the job market looking brutal? I'm Miraya. I dropped out of high school, learned to code in 6 months, and landed a full-time job at 19. No bootcamp, no internship, no degree. Now I'm 22 with over 3 years of experience. And here's the truth. Getting hired isn't the only way to make money from coding. You can build your own apps, freelance for clients, or even leverage AI tools to work faster. But when you actually understand the code, you own it. And you can do way more than just push buttons. I started freelancing because I wanted more freedom, and ended up making more money than I ever did at my job. So yeah, coding is still a gold skill. The only question is, how fast do you want to start?
So an inevitable is 41% of all code on GitHub right now is AI generated. Wow. To 6 months. ChatGPT can pass a Google Level 3 programmer exam and it will run pretty much on a MacBook or a... And that's this year. This year, right now. Yeah. There are no programmers in 5 years. So an inevitable is 41% of all code on GitHub right now is AI generated. Wow. To 6 months. ChatGPT can pass a Google Level 3 programmer exam and it will run pretty much on a MacBook or a... And that's this year. This year, right now. Yeah. There are no programmers in 5 years. So an inevitable is 41...
Is coding still worth learning now that AI can write code? The answer is absolutely yes. AI can write code snippets, they can fix bugs, and they can automate routine tasks. But the problem they have is that they don't understand the bigger picture. It's all about the context. That's where the human element comes in. Problem solving, creativity, and just being able to translate real world needs into software. So instead of AI replacing coders, it's actually just changing the way they work. Instead of a developer writing every single line of code by hand, they'll use AI, they'll guide it, they'll check its work, and coders can focus on higher level thinking. And I think that's what employers want. They don't want AI to write all of the software for their business. That's extremely risky. Instead, they want software developers who understand code and can leverage AI to produce quality software faster. So in other words, coding is still worth learning because AI won't replace developers. So if you want to learn to code and build apps, perfect timing. I just started a video series on that, lesson 1 below.
What are the top languages to learn? 5 languages to learn.
If I were to pick 5 languages that I think people should learn, I'm going to say a couple languages and you should at least explore some of them. I think you should explore a Lucy language, so Python/JavaScript, where there is truly only one type, which is a boxed value, which is a multivariate different types underneath the hood, right?
Would you call it a Lucy language?
A loosey-goosey language, right? It's a dynamic language.
Okay.
And so I think it's really good to explore one of those two. So I'd put Python or JavaScript right there. Even Lua. Throw Lua in the bunch. I think you should explore a strict language. So I'd do something like Rust, Go. I think those are both really, really great.
C++.
You can do C++. You can do some type erasure in C++. You can do it with Go as well, but it's for the most part, it's a great language to do that in.
What are the top languages to learn? 5?
So moving on to my second recommendation, this is something very different from Python, and this is C++. Now C++ is objectively a very powerful programming language. It has really unlimited use cases. Want to make a AAA game? Yeah, you can do that with C++. Want to make a website? You can do that. Want to make a compiler? You can do that. Now with that said, I will warn you, it is more challenging. This isn't something that is as beginner friendly. I wouldn't recommend most people start learning C++ as their first programming language, and this is something that's going to take longer to learn and get good at. If you're someone who just wants to learn a ton of new stuff, you want to dive into something completely different, then I would recommend C++. So moving on to my second recommendation, this is something very different from Python, and this is C++. Now C++, now everyone loves to hate on PHP, but the truth is it's very useful.
Devin is the first AI software engineer. It's going to replace a lot of tech jobs, so is computer science still worth it?
Software engineering isn't going anywhere. AI isn't going to magically replace engineers like a lot of people think, because here's what people are missing. The job isn't disappearing, it's evolving. Think about building anything complex, like a bridge, a building, a skyscraper. You need two kinds of people, the ones who can swing the hammer and the ones who can read the blueprints. Someone has to figure out what to build, how the pieces fit together, what can go wrong, and that's what's happening with software engineering right now. AI is becoming really good at the construction, at writing code, but it can't be the architect. It can't design the systems, it can't make the big decisions about what to build and how it should all fit together, it can't even reason outside its context window. And trust me, most industry problems don't fit in the context window of an AI. So look, in 10 years, AI will write a lot of code, all the boilerplate, all the repetitive stuff, but here's what it cannot do. It can't decide what to build, it can't look at a messy business problem and figure out the right technical solution, it can't make trade-offs between speed and reliability, it can barely reason across different code files, let alone massive code bases, it can't tell you if you're even building the right thing, because it doesn't think, it just does. So if you're a computer science student right now, here's the shift that you need to make. You need to stop thinking like a coder and start thinking more like an architect. Because in the future, you're not going to be hired to write every single line of code. You're going to be hired to break down vague problems into clear technical plans, to understand relationships across large code bases, to design how different parts of the system talk to each other, and to make decisions when there's no obvious right answer. And of course, you still need to understand what makes code good or bad, whether you wrote it or AI did. And here's my rule of thumb. When I'm coding something, I like to ask myself if I can do this in an interview. And if the answer is yes, and it's something that I'm confident in, then I let AI handle it. But if it's something that might even slightly trip me up on the spot, then I decide to do it myself. This way, I'm not missing any fundamental knowledge, but I still get to leverage AI's efficiency. And honestly, this is all way more interesting than just coding. You're solving the actual hard problems, focusing on the building rather than just monotonously learning syntax and language rules. And even before AI, the best engineers weren't the ones writing the most code or even writing the best code. They were the ones that were making the smartest decisions about what to build and how to build it. AI is just making that a lot more obvious. So yeah, the future of software engineering isn't just coding, it's leaning more towards a software architect role. So don't worry about AI taking your job. If anything, it's just going to make it evolve. 80% of the results you want come from a small 20% of the things that you do. And for most CS students, that 20% is just one thing, actually coding. Not watching tutorials or YouTube videos like this, not procrastinating on making a project, not doom scrolling on your phone, just actually sitting down, opening your editor, and building something. Think about it like a bodybuilder. If you want to build muscle, your 20% is lifting weights. That's the part you need to focus on because everything else is secondary. Yeah, of course, nutrition is going to matter, sleep matters, but if you're not actually in the gym lifting, none of that other stuff is going to do anything. And it's the same with software engineering and computer science as a whole, because I think most students are solely focused on going to class and attending lectures and doing your homework and getting the degree, when unfortunately all of that stuff should really be secondary in the current job market. So if you want to actually thrive as a software engineer or a student studying computer science, you should spend 80% of your time actually building something, because that's that small 20% of your entire pie that matters the most. And everything else like the networking, resume polishing, leak code, the tutorial watching, trying to get a 4.0, all of that is the other 20%. It's the icing on the cake. It helps once you're already in the rhythm of actually writing code and building something. But if you can't build, then none of that stuff really matters. But once you can, that's when you start investing in all of the other things. Then you polish your resume, then you network, then you grind leak code, then you build. ask myself if I could do this in an interview. And if the answer is yes, and it's something that I'm confident in, then I let AI handle it. But if it's something that might even slightly trip me up on the spot, then I decide to do it myself. This way, I'm not missing any fundamental knowledge, but I still get to leverage AI's efficiency. And honestly, this is all way more interesting than just coding. You're solving the actual hard problems, focusing on the building rather than just monotonously learning syntax and language rules. And even before AI, the best engineers weren't the ones writing the most code or even writing the best code. They were the ones that were making the smartest decisions about what to build and how to build it. AI is just making that a lot more obvious. So yeah, the future of software engineering isn't just coding, it's leaning more towards a software architect role. So don't worry about AI taking your job. If anything, it's just going to make it evolve. 80% of the results you want come from a small 20% of the things that you do. And for most CS students, that 20% is just one thing, actually coding. Not watching tutorials or YouTube videos like this, not procrastinating on making a project, not doom scrolling on your phone, just actually sitting down, opening your editor, and building something. Think about it like a bodybuilder. If you want to build muscle, your 20% is lifting weights. That's the part you need to focus on because everything else is secondary. Yeah, of course, nutrition is going to matter, sleep matters, but if you're not actually in the gym lifting, none of that other stuff is going to do anything. And it's the same with software engineering and computer science as a whole, because I think most students are solely focused on going to class and attending lectures and doing your homework and getting the degree, when unfortunately all of that stuff should really be secondary in the current job market. So if you want to actually thrive as a software engineer or a student studying computer science, you should spend 80% of your time actually building something, because that's that small 20% of your entire pie that matters the most. And everything else like the networking, resume polishing, leak code, the tutorial watching, trying to get a 4.0, all of that is the other 20%. It's the icing on the cake. It helps once you're already in the rhythm of actually writing code and building something, but if you can't build, then none of that stuff really matters. But once you can, that's when you start investing in all of the other things. Then you polish your resume, then you network, then you grind leak code, then you optimize your LinkedIn, because now you actually have skills to market, now you have projects to show, now you have knowledge to talk about in interviews. But if you do it the other way, if you spend all your time networking or all of your time just solely on classes, you're either going to be really generic or you're just marketing nothing for yourself. You're selling a product that doesn't exist yet. So figure out what your 20% is, the thing that will actually get you closer to your real goals, and make it 80% of your focus. Everyone's always talking about having imposter syndrome, where you're not actually bad, you just kind of feel like you are and it's all in your head. And yeah, imposter syndrome is real, but sometimes you're not dealing with imposter syndrome, you're just objectively behind. If everyone around you has internships, research experience, club involvement, cool projects, and you don't, then you're behind. That's not imposter syndrome, it's just reality. But here's the wake-up call and the good news. Most students are
The year is 2026. Your $3,500 smart fridge has a GPU and displays advertisements. Your boss is an AI. Your girlfriend is a robot. And every startup pitch sounds like Uber but quantum. Welcome to the future. It's somehow both over-engineered and still in beta, but it's time for the annual tradition where I wake up the vat of precogs in my garage and tell you exactly what's going to happen this year. Last year, I told you AI agents would be the big thing to me, you'd be a billionaire right now, but you didn't listen. In fact, I didn't even listen to myself, and now it's too late to front-run this trend. But all is not lost. There are some even bigger trends emerging in Silicon Valley right now, and as long as the record-breaking stock market doesn't crash, there's an endless supply of money being thrown around that can still make us all billionaires. In today's video, we'll look at 10 trends in technology, covering everything from AI slop to nuclear-powered quantum sex robots to new JavaScript framework features that will finally make the world a better place. It is January 14th, 2026, and you're watching the Code Report. Not everybody is cut out to become a billionaire AI grifter, but the next best thing is landing a stable, high-paying job doing some honest software engineering work. but will those jobs even exist in 2026? Unfortunately, they're coming back. After the 2023 tech pullback and the rise of AI coding tools that followed, the amount of job openings on Indeed for software engineers had not regained their original glory. But this ominous-looking chart doesn't tell the full story. On a more positive note, the Bureau of Labor Statistics is still forecasting 15% software development job growth through 2034. In addition, back in September, a major change to the H-1B program might be good news or bad news depending on who you are. If you weren't lucky enough to be born in the United States, you'll now have a $100,000 fee to apply for an H-1B visa, and that makes it far more difficult for US-based tech companies to hire cheap labor from overseas. The good news, though, is that despite what the optimists will tell you, AI coding tools are still nowhere close to replacing human engineers, and I have zero fears that that's going to change in 2026. In fact, all the vibe-coded slot out there is creating a whole new class of jobs called code janitors, who need to clean up all the garbage code created by these AI tools. It's now that LLMs as a technology have plateaued and are not actually intelligent. When GPT-5 came out a few months ago, it was a huge disappointment, and we're not seeing the exponential leaps in intelligence that a truly intelligent, self-improving AI system should be able to make. But don't get me wrong, though, the current AI technology is legit amazing. Remember, we're only a few years into this trend. Programmers were the early adopters of the prompt casino, but there are companies out there working day and night to replace stupid, smelly, squishy humans, and if you're someone who does spreadsheets for a living, is a mid-level manager, or even a graphic designer, you might no longer be necessary in the future. AI is definitely stacking up victims in the job market, and even activities that were once respected, like being a Stack Overflow poster, are now completely dead, just as I predicted a few years ago. But another sign the bubble's not over yet is the fact that most AI companies are still private. Eventually, a time will come the charade is coming to an end, and there's a good chance that wave comes in 2026. The SpaceX, OpenAI, and Anthropic are all looking to go public with some of the biggest IPOs in the history of the world. But before that happens, one of the biggest drivers to keep the AI hype going in 2026 will be robots, humanoid robots. Just a few weeks ago, 1X started taking orders for their Neo robot, which can do your laundry, wash your dishes, and just be a friendly, helpful slave that will never rebel. In addition, Figure robots and Tesla Optimus are being pushed as replacements for manual labor in factories. As of today, the tech is still pretty bad and requires a lot of teleoperation, but companies like Google and Nvidia are providing the base technology that allows any founder to Frankenstein together some clinker and raise a bunch of money. 2026 is the year we'll finally see these things roll off of assembly lines. But what if you could turn yourself into a robot or a cyborg? Well, wearable AI tech is another big trend to watch for. We've already had massive flops like the Rabbit and Humane Pin, but OpenAI is still in collaboration with Johnny Ive to make some wearable that will actually be good this time, or so they say. In addition, you've got old companies like Nike building things like battery-powered shoes that will finally allow the white man to jump. And I can't wait for the NBA to approve this and see dudes dunking from half court. But until that day comes, I'd rather just get my entertainment from virtual worlds in my VR headset. The Apple Vision Pro was supposed to finally make virtual reality mainstream, but as I correctly predicted, it was a massive flop. I got a lot of hate from Apple fanboys for making that prediction, but it's not over for the Vision Pro. There are rumors of a lower-cost version in the works that could turn this flop around. Meanwhile, Meta is making huge investments in augmented reality, but ultimately, I think the VR/AR space will mostly remain an unprofitable niche area, even though the tech itself is extremely impressive. But the lion's share of the profits are going to continue flowing into chip designers like Nvidia and ARM, and chip fabricators like Taiwan Semiconductor. AI mania has created an insatiable demand for linear algebra, and the barriers to entry in this industry are so high that these companies will continue to slurp up most of the profit. The only company that really screwed things up is Intel, which is both a chip designer and a fab. And in 2025, it looked like it was on the verge of going out of business, but luckily Trump stepped in and had the US government buy a 10% stake in Intel, thus preventing the free market from working like a free market. And Intel is poised to continue its turnaround in 2026. It's just too big to fail. But cloud providers like Azure are having a hard time even finding enough electricity to plug in their NVIDIA GPUs. As demand for AI scales up, it could lead to a resurgence in nuclear power, even as many countries in the West start to dismantle their reactors. China, on the other hand, is building all kinds of new reactors, but there are companies like Oklo, which are attempting to get regulatory approval for these small modular reactors, which could potentially give every data center its own self-contained power source. Instead of acres of these ugly intermittent solar farms or wind farms, the future might have these tiny little reactors in every neighborhood. What could possibly go wrong? And we're already seeing this play out with Zuckerberg announcing a big
big deal with Oklo to put a reactor in Ohio. But maybe this trend will never play out because computers get colder and faster, like billions of times faster, running at absolute zero temperatures. In 2025, we saw some major advancements in quantum computing, most notably with Google's Willow chip. Then, just a few months ago, Google announced its quantum echoes algorithm that measures disturbances at the subatomic scale. The first time in history, a quantum computer has actually run a verifiable algorithm that surpasses the ability of supercomputers. Quantum computers have been in development for decades now, but what's exciting is that we're finally starting to see the possibility of practical applications in the real world. When quantum computing hits version 1.0, it'll make the AI bubble look like child's play, and American and Chinese researchers are racing to get there first. But European tech leaders are also making big strides in technology, especially when it comes to water bottle caps and with the highly unpopular digital IDs, along with central bank-backed digital currencies. Despite nobody actually wanting these things, bureaucrats keep pushing them forward like it's a speed run to the Black Mirror season finale. In the near future, every government-endorsed smartphone will become a portal to your bank account, your location, your social media posts, your adult website visits, and so on. The UK has been adamant that digital IDs are coming, while the European Central Bank recently announced that the Eurozone's digital euro pilot is moving into its next phase, with the pilot program expected as soon as mid-2027 and full issuance of a digital currency by 2029. They can take our lives and they can take our freedom, but they can't take our JavaScript. On the back end, Node.js keeps getting better and better and now supports TypeScript files with typescripting. Meanwhile, Dino keeps getting better and now has its own built-in module bundler. But all the kids these days are talking about Bun.js, a runtime that keeps getting faster but also has built-in support for Postgres and Redis, making it a very tempting choice for any new JavaScript project. On the front end, React.js still dominates despite the fact it sucks, but in the future it will suck less now that the compiler is officially stable. I'd still take Svelte or Vue or even Angular over React, but there's still new JavaScript hitting the scene like Ripple, which should be on your radar in 2026. But if you're looking to level up your skills this year, like Ripple, which should be on your radar in 2026. But if you're looking to level up your skills this year, you need to check out Brilliant, the sponsor of today's video. I highly recommend their How AI Works course, which teaches you how to build a functioning language model from scratch. You'll get to experiment with things like feature vectors to edit facial expressions and images, along with other hands-on lessons that are personalized to your skill level, so you can master challenging topics over time. Check out brilliant.org/fireship to learn for free for a full 30 days, or scan the QR code on screen to get 20% off an annual premium subscription with unlimited daily access. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Alright, we're doing this. PewDiePie installing Linux, and so should you.
Oh, you little guy. Oh, you boy. You disgusting little thing. Oh, what happened to you? Oh, look at yourself. You're the blob from I Have No Mouth That I Must Scream. Oh, who did this to you? Was it Windows? Oh, Mac OS? Oh.
I hope you know that the actual video is normal looking. This is just my Linux experience. There's not actually even a joke going on right here.
Don't worry. I can save you. Install Linux. What if I told you you can look like this? Anyway, let me start this off by saying I am not a tech guy. You saw my PC building video. So bent. I'm surprised the whole thing hasn't exploded. It's like sitting next to a bomb every day. But what you did see was 0.5 seconds of the video where I installed Linux on the thing, and a lot of people just went, what? Some people seemed surprised and confused.
Something possessed him to put Linux on it.
Some people were excited. At the time, I didn't know the power that I had. I was like a baby with a rocket launcher. For years, I have been tortured by Windows. But now, alas, I am finally free! I escaped the Windows cave. I saw the sun. The shadows are gone. It blinded me for a moment. And now I'm speaking to you in the cave.
Is this how it feels to be an Arch Linux user? Is this what it's like? I use Ubuntu, so it's like I'm like a Windows user using Linux, you know what I mean? It's not even real. I'm faking it.
Enough reference. Okay, so I'm gonna yap about Linux for as long as this video is, and you're gonna listen.
I want to start off by going through the reasons why I switched to Linux. It's different for everybody. Number one is how backlit this shot is. Number one, Windows talks to me like I'm a baby. Now mentally I might be, but that does not warrant. You want Candy Crush? You want Candy Crush on your computer? You want to use Bing? Yeah. Are you sure you want to delete that file? Are you super duper sure you want to delete that?
Him doing this pisses me off, but he's very, very right. Windows does this constantly. To do anything, it's just a constant clicking of menu after menu after menu after menu, and it's just so frustrating. I hate this scene, but I hate even more that I live this life with streaming. I stream from Windows. This is Windows. That's right, everybody. I use Windows for streaming. How can you tell? Yeah. I use Windows for streaming. Yeah, you heard that.
That's why. That's how it talks to me, and I don't like it. Linux, on the other hand, literally puts a gun in your hand and says,
I just realized, I feel like I can get along with this guy. You know, I feel like I similarly express a lot of things in whatever fashion this is called. I'm sure we can be friends. Anyways, let's let him finish why you should use Linux, and then I'm going to jump in and I'll tell you why I started using Linux, which is probably a different reason than why he did.
My first sort of aha moment when I installed Linux or started using it was, wait a minute, it does exactly what I wanted to do. And this is a really powerful feeling about that. I do want to show you guys my setup as well. I will get into that. But first, reason number two. As an epic minimalist,
Dude, that is so funny that we've entered a state in our world where this is a selling point. I just want you to take a step back and really think about that. That the selling point for using Linux is it does what you tell it to do. Like, how did we get to this point? Like, how is that a selling point? How is that just not everything? I know people are saying corporate greed or capitalism just to trigger me into a 5-minute conversation about communism, but that's not it. It's more than that. And I think you guys are all guilty of this too. Watch this. We're going to do this. People, are you ready? I'm going to prove it to you. Okay, it's not corporatism. It's youism. Do you think the average person is smart? Type 1 if yes, 0 if no. I'm going to see a lot of zeros, huh? Okay. So you guys do know that there's like a lot of you in here, right? So just in case you're wondering, a lot of you are going to be on that back half of the IQ curve respectively. Not to kill you or anything, but we're going to have to call 911 to report a murder here. The reality is that everybody thinks everybody else is stupid. So we all build software and everything to have constant guardrails on to prevent stupid from happening. And stupid does happen, but we've built the world around stupid. Everything is just like, yo, people too dumb. They don't know how to delete a file without thinking that they're going to delete the operating system, so we better, like, give them 1,000 warnings. Like, that's what this is. This is just stupid.
bloat. The bloat is real. It always bothers me. Anytime I install a new Windows...
By the way, Candy Crush thing, though. Candy Crush, I hate Candy Crush, okay? Candy Crush is... I just hate games designed to just simply waste time and get you to spend money. Anyways,
that up as well. I will get into that. But first, reason number two. As an epic minimalist, the bloat. The bloat is real. It always bothered me. Anytime I install a new Windows, I spend like an hour trying to uninstall all the pre-packaged BS that I don't want. Windows is like, I know you paid $100 or whatever for me, but I'm still gonna put ads in here. Yes.
Okay, that's corporate. That one to you. Okay, that one's for you. It's true. They obviously put Candy Crush in there because they make money. And it's very annoying. I don't know how there's not just like Windows, the Windows edition. Like, can a brother just get Windows? Like, how is this not a thing? How is this just not a thing? Can I just have regular ass Windows? Windows, the Windows edition should be something they offer. Also, Copilot is just actually the... How did we arrive to the world where it's okay and it's accepted that Microsoft is going to take a snapshot of your computer every like 5 or 10 seconds, send it off to Microsoft land, and allow you to look at what you've just done? Like, how's this thing? And I know people are going to be like, oh no, it's completely offline, it doesn't actually send it anywhere. Okay, let's pretend you're 100% right and Microsoft doesn't actually do something shady and does not actually send it up for the backups and all that, and they purely are offline. How long do you think that's going to last? I mean, seriously? Siri Firefox said that it's going to be privacy first forever, and that's a promise, and not even them could hold up to their standards. Microsoft's not even could hold up to their standards. Microsoft's not even trying to be privacy first, okay? Trying to be privacy first, okay? Microsoft is intentionally saying, yo, bro, buddy, so you should use our totally free editor with our totally free service. It's just what we're doing. We're like kind people doing kind things.
Put a little AI in here. You want that, right? That doesn't benefit me. It's for you, the guy in here. You want that, right? That doesn't benefit me. It's for you, the consumer. Bing! Consumer. Bing! It doesn't benefit me that you use Bing, but... It doesn't benefit me that you use Bing, but please use off the head of Linux, and they'll say like, hey, I'm here. What's up? Customizing on Linux is called Rising, and I got way too into it. I cooked hard. I can't wait to show you guys. Now, reason number 4.
I guarantee you he's cooked way harder than me. I have the world's most minimal setup, and I don't change almost any of the defaults. Alt 1, this screen.